Chapter 6. We're moving in pretty quickly here. We've got about a chapter and a half to get through before the end of the semester. So we're going to start in chapter 6 now. Chapter 6, we're going to start out with some factoring, some basic factoring, and again, kind of build on that factoring kind of as we go along, just kind of reminding you some of the concepts from Algebra 2, and if you took pre-calc, probably didn't, but some of those concepts from Algebra 2 to make sure you get to know those, dig into them a little bit deeper, possibly, but kind of, again, just kind of preparing you for kind of the next step that you have. So Chapter 6, Section 1, we're going to look at greatest common factors and factoring by grouping today. So taking out a GCF and then, like it says, factoring by grouping. So just kind of remember when you writing a polynomial as a product of two or more simpler polynomials is called factoring the polynomial. So 3x times 5x minus 2, that's the factored form of 15x squared minus 6x. Okay, those are the different factors. And what we're going to do is we're going to start today just by taking out GCFs and then doing the factoring. And remember, factoring undoes or reverses multiplication in multiplying polynomials that we did last chapter. So we're going to kind of take what we did from last chapter and we're going to reverse it. So the first part that we're going to do today is we're going to work on taking out that greatest common factor. And this has got to be the first step anytime you're doing any type of factoring, whether it be the ones we're going to do today or even you start getting higher order polynomials. The first thing you always have to do when you're factoring is look for a greatest common factor. One of the errors that you probably had quite a bit in Algebra 2, and some of the calc students, a lot of the calc students have the issue is they forget to take out a greatest common factor right away. And if you don't take out that greatest common factor first, before you even try to do anything else, you're going to run into a lot of problems. So what the greatest common factor is the greatest common factor is the largest term that is a factor of all of the terms of the polynomial. So whether it's 2 terms, 6 terms, 27 terms, the greatest common factor is going to be something that each one of those terms has in common. So for example, if we want to factor out the greatest common factor of 7k and 28, we have to figure out, well, what's a common factor between 7k and the other term 28. So you could go in here and then you could list all the different factors of the numbers, and you've got a 7, you've got a 1, you've got the k there, that's kind of a factor as well. For 28, you've got 1, you've got 2, you've got 4, you've got 7, you've got 14 and 28. Well, we can only look at the one that they have in common. And the only one that they have in common in this case is 7. So that's going to be our greatest common factor for this. So we're going to sense in the imagination, we're going to factor that common factor out. So we're going to take a 7 out of there. Well, what does that mean? That essentially means that you're going to take each of these terms and you're going to divide each of these terms by 7. And then the result of what's left is what's going to go inside of your parentheses. So if I take 7k divided by 7, the 7's cancel out, and I'm just left with k. Plus, if I take 28 divided by 7, 28 divided by 7 is 4. Now I've factored out the greatest common factor. And again, you can always double check these to make sure by distributing in, doing the multiplication that we did in chapter 5, you get 7k plus 7 times 4 is 28. It checks out, and you get the solution that you're supposed to get. But it's taking out that greatest common factor and figuring out exactly what that common factor is. Okay, let's look at the next one. You got 32m plus 32. And again, we could list all the factors for 32 and we could list all the factors for 24 and figure out which one they have in common, or for 32m and 24 and figure out which ones they have in common. And it's got to be the greatest one that they have in common. So 1 times 32, 2 times 16, 4 times 8. I think that's it. And then we've got the m sitting in there. At 24 is 1 and 24, 2 and 12, 3 and 8, 6 and 4. So if we look at the common one that they have, we've got an 8 and an 8. So our common factor for this is going to be 8. So that essentially means that we're going to take each of these pieces and divide by 8. 32 divided by 8 is 4, and we've got an m there. 24 divided by 8 is 3, and you've got a 3 there. So this becomes your solution, taking out the greatest common factor. Well, what happens if, say, that instead of taking out a greatest common factor, you just took out a common factor? And you'll notice they both have a common factor here of 4. So what happens if I take a 4 out of there instead? Well, then I'm going to take 32m and I'm going to divide it by 4. And I'm going to take 24 and divide it by 4. So that becomes 8m plus 6. Now what you should notice is that the 8m plus 6, they have a greatest common factor that could be taken out of them as well. You could take a 2 out. So if you take a 2 out, you got to take the 2 times the 4 and you get 8, and you get 4m plus 6. I mean, you get the same solution, but you have to do an additional step. That's why you always want to make sure that you have the greatest common factor. And in most cases, you're not going to have to do this over here. You should be, I mean, you've been doing math for a long time. You should be able to figure out what the greatest common factor is really at a pretty good clip at this point. So again, there's their explanation for it, and so on and so forth. So now we've got 3 terms, and now we've got a bunch of different things in here. We've got m's in here as well. So now we got to deal with variables, and we're dealing with variables. Each of them has to have that variable, and you go by the least exponent that any of them have. So in this case, they all have m's. So m is going to be a common variable that it has. Now the least exponent of the m's is m to the third. So that's part of what I'm going to take out, just variable-wise. Now we look at the numbers, 100, 50, and 25. I'm not going to list them all. I mean, you should be able to say, okay, 25 is what I'm going to take out of there. So I'm going to take 25m cubed out of each of these. So I'm going to divide by 25m cubed. 25m cubed and 25m cubed. 100 divided by 25 is 4. M to the 5th divided by m to the 3rd. 5 minus 3 is 2, so that becomes m squared. Minus, because there's a minus symbol. 50 divided by 25 is 2. 4 and 3 gives me m. Plus 25 divided by 25 is 1. M cubed divided by m cubed is 1. We have to put that plus 1. That's our solution. And again, you could go through and check that if you thought you needed to. Okay? So there's taking out the greatest common factor for that one. Okay? Here's their explanation. They found the GCF. They found it. Wow, long explanation. It is what it is. Okay? So I want you to write this one down, and I want you to go ahead and find the GCF of this one. I'll give you about 30 seconds or so, and then I'll go ahead and solve the problem with you. So go ahead, try this one on your own. We'll come back together in about 30 seconds with the solution. We're back. Greatest common factor you should have had. 5m to the 4th, x to the 3rd. Now, I'm not going to write the division out all the time. 5 divided by 5 is 1. 4 and 4 goes away. So that leaves me with 1. Plus 15 divided by 5 is 3. 5 and 4, that leaves me with 1. 6 and 3, that leaves me with 3 x's. Minus 20 divided by 5 is 4. M's go away. X to the 3rd. Now, in my mind, I'm going through and checking it to make sure that it looks right and it works out. It appears to. there's your solution taking out the GCF. Kind of freaky me just staring at the thing, isn't it? Okay. And there's their explanation. The same thing we got. So in this case, now, I mean, you're still going to factor out a GCF for each of the terms, and you look at the GCF of both terms. Well, inside of parentheses, that's a term, okay? It's a different way to write, but that's just really one term. So what do these have in common? Well, both of these have an a plus 2. So they have an a plus 2 in common. So we can take that out. But then what that leaves us is, if I take an a plus 2 out of the first one, that leaves me with a minus 3, and I need to put that in parentheses, plus, well, what's here? A plus 6. So you be a little bit careful with how you write this one, but that's taking out a GCF. The GCF just so happens to be a plus 2 in that, and that's okay. You can still just take that out and get an explanation for it. Now, of course, we could eliminate those if we wanted to, and we could simplify this further. But, you know, whatever. That's how it's simplified, and I mean, I think you could have seen that from my directions up there. I mean, you could have seen how to do that, but there's nothing wrong with how I had it either. Okay. Again, a little bit more complex of a question with this one, but let's think about what they have in common. And remember that this is a term, and this is a term, and they kind of have that in common. But how many are here? There are 2 here, and there are 1 here. So my GCF for this is actually going to be a plus 5b. And when I take that out, I'm left with k squared plus m squared times a plus 5b. Because I had 2 of them, I still have to have 1 of them sitting out there. And now, again, you could simplify this a little bit further if you wanted to, but again, it becomes about taking out that GCF. And this is a pretty complex one, but you certainly could. And again, you could simplify it if you wanted to. Okay, in this case, you should be able to do this pretty quickly. One of the nice things about when you do factors, if you've got a negative in there, if your first term is negative, and like in this case, we've got negative 6r squared, that leading coefficient, we like the leading coefficient to be positive if possible. So I'm going to pull that negative out. I'm going to factor that negative out, but they also have a common factor in this case of r. So I'm actually going to divide each of these by negative r, and I'm going to use that negative as a factor because I'd rather have my first term, which is now just 6r, I would rather have that positive. And then the minus, so it's going to be 6r minus 5 is going to be one of the ways to do this. The other way would be to just not take out the negative. But we like to have that leading coefficient to be positive if we possibly can. So try to pull out a negative as your GCF in those cases. Okay? And they just did it 2 different ways. So our second objective then is to, how do we go about factoring by grouping? So sometimes individual terms of a polynomial have the greatest common factor of 1, but it still may be possible to factor the polynomial using a process called factoring by grouping. We usually factor by grouping when a polynomial has 3 or more terms. So in this case, there are 4 terms. So when we're going to factor by grouping, we're going to group terms together, meaning we're going to group the first 2 terms with the last 2 terms, and we're going to take a greatest common factor out of each of those pieces. So in this case, if we look at the first 2 terms, and I don't know why I continue to use this color, but if I look at those 2 terms, I can take a GCF out of there. And if I take a greatest common factor out of just those 2, I'm going to take out a 6. And that's going to leave me with P minus Q. Plus, now I'm going to look for a GCF of those. And a GCF for those is R. Since R is a GCF for those, that's also going to leave me with P minus Q. Now, because we're factoring by grouping, I could continue to factor this. Because both of these terms have P minus Q, I could take a P minus Q out of there. And if I take a P minus Q out of this first one, I'm left with a 6. If I take a P minus Q out of this second one, I'm left with an R. So that is the factored form of this. And that's done by factoring by grouping. Okay, now this is how I do it. Okay, let's see how the book does it. See if they do it any different way. So they group the terms as follows, just like I did. And they turned it around a little bit. They just reordered it. It's no different. Okay, so they decided they wanted to put the Q's together. It doesn't matter. You'll notice that they're going to get the same answer that we got. They just did it a little different way. And they just rearranged it because for some reason they wanted the P's and the R's. But we just took the 6's and left it alone. And there's nothing wrong with that. You get the same solution even if you move things around a little bit. Okay, so let's look at the second one. Okay. Now I'm not going to rearrange it. There's no reason to rearrange this. But there's 4 terms. So that means I'm going to factor by grouping. But remember what your first thing always has to be when you're factoring is look for a GCF. Is there a GCF in there? They don't all have X's, they don't all have Y's, and they don't all have numbers. So there's no GCF to take out of there. So since there's not a GCF to take out of there, then we can just go ahead and factor by grouping. So we group the first 2 terms together. Common factor that they have is Y. If I take a Y out of there, that leaves me with X minus 2. Now this gets a little tricky because of this minus symbol. Greatest common factor is 4. So we're going to take a 4 out of there. But notice we're taking a negative 4 out of there. So that means I need to take each of these pieces and divide by negative 4 because I've got a negative 4 sitting right here. So negative 4x divided by negative 4, that just leaves me with x. 8 divided by negative 4 is minus 2. Now you'll notice that these 2 things are the same. That's really what we want to happen. So we can factor out an x minus 2. If we factor out an x minus 2 from the first, we're left with y. If we factor out a minus 2 from there, we're left with y minus 4. So there's the factored form of this one done by grouping. Okay. Look at their explanation. Again, looks like they probably rewrote it, but got the same thing. Their steps. They collect the terms into groups. Most of the time it's going to be done for you already. Factor within the groups and then factor the impiled term name. And again, you could always check these if you wanted to. Okay. Let's look at a couple more examples. Common factor for the first 2 terms is K. Oh, geez, it's not K, bonehead. Common factor is N. That leaves me with K plus M minus. Well, do those really have a common factor other than 1? No, not really, but we have to put minus 1 out there because we need to factor something out. So if the common factor is 1 and you're factoring by grouping, just bring out that negative 1. So now remember, we're going to take each of these terms and divide by negative 1. So if we take a negative 1 out of there, negative k divided by negative 1, that just leaves me with k. A minus and a minus leaves me with a plus, and then we've got a k plus m. So now if I take that k plus m out, that leaves me with n minus 1. That's your solution then by grouping them. So make sure if their common factor is 1, do make sure that you take that 1 out of there. And also keep in mind if it is negative, make sure that you divide each of them by negative. You're essentially going to change the signs for both of them, right? And there's another example, but that's really that's what we were going through today. So we're able to factor out using the greatest common factor and factoring by grouping.